Okay, this is quality assurance for small software publishers, and looking at me, you can see that I don't mean small people that are software publishers. I also don't mean small software publishers that publish small software. Actually, what this is for, generally for developers who don't have the means or the volume of having a separate quality assurance department. So, talking about the things that programmers and developers in general can do to make their product better. I kind of wish that a talk like this would be unnecessary, but my experience tells me it's not. But the ironic thing is that probably by self-selecting and being in this, you are the people here that need this the least. So that's what we're going to talk about today. The reasons, methods, techniques, and tools for performing testing and quality assurance for self-published software. So, quick overview. In the first part, I'm going to talk about definition and purpose of quality assurance. In the second part, which is going to be a little lengthy and slightly technical, I'm going to discuss programming and build techniques and related tools that can enhance the robustness of your product. In part 3, I'll discuss product testing process, including various aspects of alpha and beta testing. And in part 4, which is really short, I'll cover a few aspects of quality assurance that take place after the product's released, including customer support and product updates. So, here's the introduction to me. Gregg Seelhoff. I'm principal at Digital Gamecraft. In that role, I also do a lot of work with good solid development. I was a former ASP chairman of the board. I've been a programmer professionally for 33 years and an independent full-time developer for 17 years. But as I note, I'm not a PowerPoint professional, so I'm hoping that my content makes up for my lack of presentation skills. And I'll have better contact information at the end. So the real thing you want to know is, why should you listen to me? And so I'm going to give you a quick rundown of a couple of stories from my quality assurance past. I released a DOS game in 1990, the first shareware release I had, and it got massive distribution, was featured in a couple of books, it was featured in the shareware column of PC Gamer magazine, and in 5 years I had one bug report. No updates, one bug report ever. Now I can tell you guys there was actually a second bug that I found that nobody ever reported. And just for a control, you can take from that in 5 years, I only had one bug report, and then when Windows 95 came out, they introduced a glitch in the way it handled DOS games from the Windows 95 desktop. And in 1995 and 1996, I got several customer support inquiries a month for this little glitch, which the result of it is if somebody got overexcited with a slow computer and double-clicked on the icon twice, that when it exited my program, it would then immediately relaunch my program. Needless to say, people weren't very happy because they thought my program had taken over their computer. I worked at Spectrum Holobyte in 1993 and 94, working on a product called Star Trek Next Generation Final Unity as a senior software engineer. But another thing that I did is a companion product that was out for the Sega Genesis, or was getting prepared for the Sega Genesis. Spectrum Holobyte decided to do bug hunts. And they gave $100 to whoever had the most bugs found, $100 to whoever had the best, most obscure bug. So the first one, I got both $100 prizes. So they changed the rules, said you can't win both. So in the second one, I would have won both, but I only got one. And then after that, they said, well, you know what? Why don't you just do the bug hunt and turn in your bugs at the end, which I complied. And then they offered me, then the QA manager offered me a job in the QA department for half of what I was making as the senior software engineer in the Star Trek title. I turned it down. In Windows 98 SE, just as a consumer, I was in the beta team. They had a bug hunt. I turned in a few hundred bugs, won that, and still have a shrink-wrapped copy of Visual Studio 6 as my trophy sitting on my shelf. I think the value is going up now. I interviewed for a quality assurance program, quality assurance position with a company that does external testing for products. And they gave me a little test. They said, here, we're going to have you do some, look at this function and see where there might be bugs, where there are bugs, where there could be bugs, depending on the parameters that are passed in. I returned a 2-page email with all of the different bugs, and the guy got back to me and said, well, you actually found things that our test preparer didn't plan on. And then these last two, I worked on a product with Microsoft called Microsoft Plus Cards and Puzzles that was released with Windows at the same time as Windows ME. Unfortunately, because we were done for Windows 2000, and if it had been released with Windows 2000 instead of sitting on the shelf for 6 months, we would have done a lot better. In Microsoft's internal testing, I had 2 bugs filed against my networking code, and went round and around and around with them. And then finally, when we got down to the heart of the matter, it turns out that the 2 bugs that I swore were not my bugs and could prove, it turns out that one was a bug in Windows ME and the other was a bug in DirectX. So I'm 2-0 against Microsoft. And then just this year, Apple rejected one of our products that had been in the Mac App Store. We did a minor update, and they rejected it right about the same time that they were adding the sandboxing requirement, the first time before they extended the deadline. And it took us about 2 weeks to finally convince Apple to go back in and take a look after we had checked every conceivable way that it could be failing and be our fault. And we finally did prove to Apple that when they put in the sandboxing, they had introduced some new testing tools, and the bug was in their testing tool and not in our product. So that gives you a little idea of the experience I've got with quality assurance. So start with the definition. Here's the definition. Don't read it too hard, because this definition sucks. So I'm going to translate it. Translation is making your products and customer service the best they can be. That's what quality assurance is all about. It's all about the product, and the product including the services that you provide. It includes things like your ordering pages, your website, and it's also about the customer's experience. If the customers don't experience it, it's irrelevant. And if the customers have a bad experience, then that's bad quality assurance. So the principles of quality assurance, the basic principles are that your product works properly, which means it doesn't crash, it's close to bug-free, and it's fit for the purpose. So it does the job, it's easy to use. Note that it's not just bugs. It can also be design issues that make it hard to use or confusing. And it's not just testing. Quality assurance is much more than just testing. So the goals are you want to reduce customer dissatisfaction. You'll always have some customers that will be dissatisfied with one thing or another. But you want to reduce that dissatisfaction, and you want to eliminate any place where the customer actually gets frustrated with you. So, why? Does anybody have any thoughts why we want to focus on quality assurance? Throw some things out. Guess what the next slide's going to be? Rosemary.
Reduces customer support.
That's a great one. And that's also, I should say that I actually attended a talk by Rosemary years and years and years ago where she was telling me about the customer support. So, Albert.
You don't want people talking bad about your software.
Right, that's a good one. That's a good one.
Sell more software.
Sell more software. Okay, those are good. Those are 3 great ones, and they are on the slide after the next one. But I contend that the main reason that you want to worry about quality assurance is for better inertia. So for those of you that don't know what this is about, a certain current presidential candidate put out an iOS app to try to boost his campaign, and used this as the base image. And well, does that instill confidence in you at all? So that's what we don't want to have happen. So the purpose is we want to have better software, positive reviews, good word of mouth, fewer support issues, and more sales. So the things you guys were talking about. A lot of times, most of this is referred to simply as goodwill. And just to note the support issue that was brought up, is the rule of thumb for retail games used to be, I haven't been in retail games for a while, but it used to be that they budgeted $1 per sale for customer support. So fewer support issues saves you money, more sales makes you money. And that's what we're going after with better quality assurance. So the components of quality assurance are development techniques that help your software be robust in the first place, alpha, internal testing, beta testing, whether open or closed, and we'll talk about that a bit, logging and reporting, so ways that you find out about issues and track them down, customer support, and everything else. In a broad sense, quality assurance is really a marketing function because we want to have that goodwill. And it's also not it's a cycle. It's not discrete steps. You don't go, okay, I'm done with development, now I'm going to test, and I'm going to do my internal testing, and now I'm going to, you want to be working on some aspects of the quality assurance all the time, and it loops around. Once you get done with beta testing, you release your product, you do customer support, which is going to bring in some more bug reports, and then you're back to development, how you could have caught those bugs in the first place, alpha testing, beta testing, a new update. So, the most important thing that I want to instill today is it's all about the attitude. You want to have a positive attitude towards quality assurance. You want to give it a priority among your business values. You want to take pride in the quality of your products and services. And remember that the problem reports help you improve. So every time you find out that something's wrong with your software, it can be very hard when people report something is wrong with your software, especially when they're rude. And even more especially when they're rude and non-specific, like it sucks. But remember that any problem reports are an opportunity for you to improve your software or your process. And also, tracking and killing bugs can be fun. So if you think of it as a game, then it makes it a little bit more enjoyable. And it is pretty satisfying when it takes you, it takes you a day to track down a bug, and then when you finally find it and you kill it, and you can confirm that it's dead. That can be pretty satisfying. So note that one thing that's not on here is the quote, "It works here," which a lot of people say, and that's a bad idea for your quality assurance. So a little quote here that I used to tell people 30 years ago, and it's still true today. All software has bugs. You can't have perfect software, at least not, and still get your software out the door to release to customers. If all you have to do is run it on your computer and it does something very simple, then maybe you can be bug free, but probably not. So let's discuss what a bug is. A bug is a failure of your product to perform correctly. An error message or a crash, or just being confusing, somebody can't figure out how to do something, these are all bugs. So I've got the keywords up here that I can think of. Aside from bug, we've got error, flaw, mistake, failure, fault, issue, crash, freeze, lockup, glitch, artifact, and problem. I was wondering, does anybody have any other things that words they use to describe a bug that isn't in that list? Feature. Thank you, Andre. That's very good. Yeah. So in the book No Bugs by David Thalen, he suggested the alternative MFU for a massive, we'll say, foul up. And what the idea that he suggested that you should call it an MFU because a bug sort of implies that it's something external that happened to you. Whereas an MFU acknowledges that it's usually your fault and it's almost always your problem to resolve. When we're looking at bugs, we classify our bugs on a scale of 1 to 5. Now this is just something that we do internally. Every place that I've actually dealt with on a QA basis has always used the 1 to 5 standard. But if you want to get particular, you can do 10, you can do 7. Whatever works, but it's a good way to prioritize bugs. Number 1 is a showstopper. That's a bug where your program does not work, period. It does not function. It crashes when you try to start. It doesn't do something when you try to start. It's a program that its job is to print, and it doesn't print. Two is a major bug, which is one that you just can't allow to be out in the open. You've got to fix right away. Standard errors, are bugs where something doesn't function right, but you can maybe wait for your next update cycle. You don't have to rush out a fix today. And 4 is minor issues, which would be things like misspellings, glitches in your artwork, or something that doesn't affect the way that the customer uses the software, just makes it look a little worse, or something like that. And then, of course, suggestions. And you do, when you're dealing with other people testing your product, you get suggestions a lot. And it's good to have a suggestion category, so that you can look at ways that you might improve your product, but not prioritize them. For instance, your Pac-Man game should really be able to print out the maze. All right, we'll put that down as suggestion, because we can look at it later. And then we also use a similar scale for features, where 1 is the essential core functionality, which is the whole point of the product. 2 would be a required or must-have feature. 3 are the planned or desirable features that you can drop if you get tight on time, tight on money. 4 are minor features, obscure features. If we have time, maybe the next version. And then 5 is a wish list, features that you might look at later, or you may never look at seriously. Did you have a question?
Well, more observation. The premise here, I think, is that you have enough bugs that you actually have a list that you want to manage. The alternative is that you simply stop, fix it, that you don't move on until you nail it.
Right, and
then classifying it's irrelevant.
So to clarify, Dennis is pointing out that classifying it is irrelevant. When, from a developer perspective, it should be. You fix it before you move on. But when your beta version meets the real world, you will have some of these. Depending on the complexity of your product, you'll have more or less. It should be more or fewer. On our games, that really is true, Dennis. That we don't have a lot of bug reports. It can be frustrating because sometimes the beta testers find far fewer bugs than I do after I ship, even though I've tried to get rid of them all. But on the other hand, for instance, that Microsoft Plus product I was talking about, once it hit a dedicated QA department, they came up with 400 or 500 bugs. So if you get the right guys, they'll go through your help file and get all of your mistakes, things that don't quite match up with what the program's doing, things that have gotten obsolete since the last version, and so it's good to be able to classify them. So this is where we start talking about development. And so just in general, I want to point out that bugs will happen, and we're not really looking for perfection. But remember that bugs aren't forever. You get a bug, you can fix it. And the programmer is the first line of defense. So programmers must test everything first. And that follows on with what Dennis just said. I mean, if you're a developer and you find a bug, you fix it at that point. And they're always cheaper. Bugs are always cheaper to fix early on. The only bug that's cheaper to fix than an early bug is a bug that's automatically detected or never exists in the first place. And that's why these questions are here. When bugs occur, you need to ask yourself, how could I have prevented this bug? And how could I have automatically detected this bug? Now, sometimes there may be no way to do it, but sometimes you can put in a process, sometimes you can put in a piece of code that will allow you to automatically find problems in your software, so that when you run them the first time, or even when you compile them, they'll basically stand up and say, hey, I'm here, squash me. I'm going to ask everybody here, how many people actually use a different release and debug version when they're developing? Okay, that's far fewer than I was hoping. So really, one thing that's really important to do to have good quality assurance is to have a release version and debug version that are compile from the same source with conditional compilation. So in Visual C++, for instance, it defines debug if you're running a debug version. And then you can put in extra checking into your program that's in the debug version. It might be really slow. You might not want it in the release version, but it will verify that everything is happening the way you expect it to be happening within your program. So the release version it has your code optimized with no debug checking. The debug version has all the debug checking, but it's not optimized, simply because if you optimize it, then the debugger gets very confused and your line pointers jump up and down, and you can't figure out where the code is going. And then some people do a checked version. Now, a checked version is a version that has all the debug checking in it, but is optimized and has all of the debug objects stripped out of it. In other words, you're not shipping the names of all your functions and the names of all your classes and enough information for your program to be run in a debugger by somebody else. So the release version is for customers, although you do need to test the release version. Maybe not quite as much as the debug version, but you got to make sure you test both the release and the debug versions. The checked version can be used to send out to testers, can be used to send out to customers who have a problem that you can't figure out why something is not working, and then you can send them a checked version they can run, and if any of your debug assertions or logging flags something, then you'll be able to get that back. And then of course, you can combine those with the different versions that you might be creating for other reasons, like a separate trial and full version. We've got a Mac App Store version of all our Mac products, simply because the Mac App Store has such rigid requirements for certain things that they're incompatible with a Mac OS X product, so we have a slightly different build. And just as an example of that, all of our Mac products run on Intel and PowerPC chips. But if you submit a product to the Mac App Store that runs on PowerPC, even though it wouldn't use it, they will reject it because they don't want to support PowerPC anymore. So the first tool that you've got in your toolbox is your compiler. So I'm going to look at this first one. Enable all warnings. How many people start by enabling all the warnings in their projects? Okay, we got 1, 2, 3, 4. Okay. You want to enable all the warnings. Warnings are there for a good reason, and even if your code runs now, it may break in another circumstance. It may break when you optimize for the release version. It may break in a minor compiler update. It may break when you try to port it to another program or to another system. And so it's a good idea to start by enabling all your warnings. Never ignore warnings. And if you can, if your compiler has a treat all warnings as errors switch, it's good to turn that on so that you can't ignore warnings. The reason that you never want to ignore warnings, I know a lot of people say, well, that's not an important warning, that's not an important warning, that's not an important warning, and then they ignore them, and you become blind. So you know that when you compile, your Windows throws up a whole bunch of warnings, and you don't notice something new because it's drowned out by all these warnings that you've grown accustomed to ignoring. I tell you what, if I'm running my compiler and I compile my project, if something pops up, a warning or an error, I know about it. It stands right out because usually it just says 0 warnings, 0 errors, and I'm good. So that's the main reason that you don't want to ignore warnings. Even though they may be innocuous, you still don't want to ignore them. If you have to, as a last resort, you can disable them. Some tools allow you to use like a pragma or something to disable them in just a certain function, and that's the best way to do it. Turn off a single warning in a single function where you've already tested to make sure that is not a problem. Sometimes we have warnings thrown up in something that optimizes incorrectly with the compiler, so you want to turn that warning off and do what you know you need to do to make the compiler work. And for interpreted code, there isn't really an equivalent, but you should make sure that every line is properly executed. So if you can step through interpreted code and make sure that syntactically it doesn't throw up any errors, That's the closest I can come to for interpreted code. I'm going to tell you one story of why you want to make sure that your code make sure that your code doesn't throw any warnings. When I worked with a company called Zombie, they made games, still make games. We were working on a product called ZPC, No Flesh Shall Be Spared, which is a shooter, and is based on on an engine by Bungie, who went on to do Halo, so you may have heard of them. And there was some code in there. We were doing both Windows and Mac version at the same time, and I was only working on the Windows side. And there was some code in there that the Mac developer had been ignoring, had been throwing up some warnings. And since we were working on the same code base, one of the Windows programmers went in and changed just the order of declaration of these variables, and it broke the Mac version, and the Mac version crashed immediately. Because it turns out the warning was warning about the reliance of the stack order of the variables, which is a terrible thing to do, but it was working just fine, and so they were ignoring the warnings, and then all somebody did is declare A before they declared B, and the Mac version crashed. Surprisingly, the Mac programmer was mad at us for having made a change. So the next tool that you can use to make robust programs is static analysis. Now, static analysis is basically compiler warnings on steroids. This is taking it to the next step. Rather than just giving you warnings because the compiler's not sure what code it needs to, what code it needs to make into the program, the static analysis will actually go through and look for all sorts of little specific things that might cause a problem with porting, might cause a problem with null pointers, all sorts of things. Issues like unused or uninitialized variables. Usually, when you have an unused variable, it means that sometimes it means you just forgot to take something out, but sometimes it means that you meant to use a different variable and you forgot to change something. Unusual constructs. Sometimes it'll flag things like if you say if something equals something else when you're actually doing an assignment instead of an equivalency, which means you're changing the variable. That's not something that you generally are intending to do, and it'll flag things like that even though they're syntactically perfectly correct. Portability issues, and even violations of coding standards. Now, my first note is PC-lint. I'm a really, really big fan of PC-lint. I think PC-lint is, aside from my compilers, is the number one tool in my toolbox. But it is, of course, limited to C and C++, so it won't help you much if you're doing Delphi development or even Objective-C. But if you happen to be working in C or C++, PC-lint is fantastic.
Is that a free program, or is that?
It is not a free program. It's inexpensive for what it is, but it's reasonably expensive. It's I think $239, something like that. I should have looked that up beforehand. It's from Gimple. I have it on the tools I have it on the tools page. They've been around for a long time. I've been using it for 17 years, and it actually has made me a better programmer. Just seeing what things are flagged and then reading why they're flagged has made me a much better programmer. I mean, years ago I would have looked at that other example I talked about and said, okay, I've got two variables declared and one happens to read into the other one. Wouldn't have bothered me at all, but PC-lint will go ape on that. Now the analyze feature that's in in some of the new compilers, GNU compilers, available for OS X, iOS, Linux. They do have static analysis built in. I believe the later versions of Visual Studio also have static analysis built in, and so use those. And multiple options are better. So if you have PC-lint and you happen to have Visual Studio 12 and run static analysis in that's a good idea. I actually know game programmers who make sure that their code runs, compiles in 2 separate compilers just to make sure that all the checks are there. In this case, you do the same thing that you wanted to do with the compiler. You start by enabling all the warnings, but because the whole point of static analysis is to be very picky, you'll probably find out there's some warnings that are just too picky to worry about. For instance, I usually disable the warning about converting longs to integers because it just happens so much in standard Windows code that you would be forever just trying to get that straightened out and put all the casts in and whatnot. Next step, assertions. All right, how many people use assertions in their code? Okay, that's pretty good. That's more like what I want to see. So you guys know what assertions are. For those who don't, assertions are simple statements that assert that something is true, and that will flag a problem if it's not true. So you can use an assertion to validate any coding assumption. So if you assume that this function is only going to get called with a parameter in the range of 1 to 5, you can assert that the parameter is not less than 1. You can assert the parameter is not more than 5. You can especially the verifying that pointers are not null prior to the first access in a routine. So you might have a class variable, static class variable, that when you're calling initializing your class, it always gets set, and you can count on it as being a pointer to, say, a class that draws things on the screen. And you set it just once when you initialize the class, so you can assume that it's going to not be null, and you aren't going to crash. But with an assertion, before you use it in every routine, you make sure that it's not null. And if it comes up null, then you know something didn't get initialized right or something got overwritten. And I should point out that there are other variations of the assert, the verify or check, which are pretty much the same thing, except that they generally assertions are intended that if it's not true, it assumes that you just simply stop. Whereas verify or check, whatever terminology they use, would be one that sort of assumes that you will continue on anyways. And in terms of actual code, there's no real difference. In terms of documentation, we end up using verify is what we use to say that we're making sure that this is correct, but then we still handle it just in case. So instead of just making sure that pointer is not null and then using it, we make sure that pointer is not null and then follow it up immediately with it. If it is null, return an error code. Let's see. You only want to assert on a single expression, simply because generally assertions will print out what line the error happens on. And if you're checking a parameter to see if it's between 1 and 5, if you check that all as 1, it'll just say the parameter is no good. But if you check it, make sure it's not below 1, make sure it's not above 5, then when the assertion flags, you know which it was. And never put operations in an assertion. It's something that seems pretty obvious, but it's easy to do occasionally. You'll assert that something, you'll assert a variable, calling another equals a parameter, a function, and then check that that's equivalent to something. And then what you're doing is changing the variable only in your debug version and not in your release version, and so you get different behavior. Does that make sense? You guys mostly know about assertions, so we'll move on. Coding standards are really important. Practice defensive coding. Now I know coding standards don't seem like they make much sense as a one programmer shop like we are. But coding standards are important because if you're using coding standards and you see something doesn't match the coding standard, you know that you've done something that you didn't quite intend to do. You should handle let's see, I already mentioned the handling potential issues even if they be caught by an assertion. These are just some ideas for what you would have for coding standards. Simplifying functions. Our standards are that if a function doesn't fit on one screen of the editor, then it's probably too complex, it's probably too long, and if it doesn't fit in 2, then we definitely break it into separate pieces. Prefer obvious constructs over clever implementations. You could, for instance, use a tertiary operator to say if, set A to, if this is, one value, set it to that. If it's, if it's true, set it to that. If it's false, set it to, and then use another one and tag another one on top of it. So you could get it all onto one line. And that's what we used to think was really cool back in high school. Wow, you could get all this stuff on one line. It's terrible to read. So it's better to actually use simple constructs. You're not going to impress any customers with how complex and clever your code is. And so if you say A equals X times 2, and then in the next line you say B equals A times 4, you could put it all on one line, but then it's very clear what you're doing if you make it simple. That's a little too simple. But. And follow a naming convention, because that way when whatever the naming convention happens to be, that way when you look at a variable, you know how you intended to use it. Let's see, other things. Intermediate variables, it's a good idea to use intermediate variables, like I mentioned, and verify validity rather than try to put everything all in one line. Especially never string pointers together. So don't do a pointer pointing to something that's a pointer to something else. Always break those into 2 lines so that you can verify, you can assert that the first pointer is not null, and then you can, once you get the return pointer, you can verify also that that's not null before you access it. And one thing that I didn't put up here, but I hear a lot of people saying in the shareware community about dealing with hackers. A lot of people will say, oh, well, in this case, if they do this, I just crash the program. I'm just going to say, I think that's a terrible, terrible idea, because no matter what, even if they may have been stealing it, it's going to give your program the reputation of crashing. Even if, because they don't think, oh, I stole this, it's probably crashing because I did this. They're going to say, oh, no, this program is garbage. And they will spread the word about that. And let's see, tracking and logging. You should include a method in your debug version for tracking functions and status messages. That would be things like an iOS is particularly useful because you have to know when functions are getting called. It's easy to visually see if you have it logging when it goes into the will change orientation routine and then did change orientation routine. And that's helpful for envisioning what your program's actually doing on event-driven programming. And also status messages, so that you can just make sure that things are working okay. You have a print that prints only in your debug version that prints status messages that won't show up in the release version. Generally, just simply having a routine that writes to the standard error handler in Visual Studio, that'll show up in the bottom box when it runs the debug. Very simple. And then you want to have a method that you use for error reporting and logging, things that you want to find out about if your customer runs into them. So if they get an error message, when you throw up your dialog, you should also write something to a log that you can later have them send to you or automatically send. Now, one thing that we do is we add custom hardware exception handling with diagnostic information. And the reason I say custom, if your program actually crashes, for instance on Windows, it'll throw up, say, this experienced an exception at, and it throws up a bunch of ugly numbers to the customer. And then I think nowadays Microsoft offers to let them send the report about your bad software to Microsoft. If you do a custom hardware exception handler, either through a tool, a library, or write it yourself, then you can catch that. So if you access a null pointer, you can actually get it and give them a nice text saying, I'm sorry, something went wrong with our program. Please send this error log to this support address. And you don't have to show them all the garbage. You can put the stack dump and all the other stuff that would normally intimidate users. And then all they see is a dialog box saying, something went wrong, we're closing the program, please send this and we'll try to make it better. And then last, an easy method for retrieving the logs when the errors occur. I have to admit that we're not very good at that. but there is a tool for Delphi and C++ Builder that I'll mention that I think actually allows you to automatically have it emailed directly to you. There's another way if you sign up with Microsoft and you go through all of their programs, those reports that get sent to Microsoft can then come back to you, and you can figure out what's wrong from those. Let's see, integrity checks. It's a good idea to put integrity checks in your program just to make sure everything's working the way you expect it to be working. So memory management tools. There are a lot of things built into to Windows and Mac libraries that allow you to actually just verify that you're not getting buffer overruns, verify you're not accessing any dangling pointers, and also routines that allow you to verify pointers or handles that they're still valid. Validation functions or custom functions you write to make sure that something is valid in the context of your program. So, for instance, we have a sprite routine that has a long linked list of sprites from front to back. And so in our debug version, we have a validation function that every time the list is manipulated, it goes through and verifies start to finish that linked list is still valid. And so if I make a bug in the code that causes the linked list to get corrupted, I know immediately because the validation function will flag it immediately. And redundant algorithms. If you have an algorithm that does something very efficiently, but it's confusing, you might want to write a second algorithm and then compare run them both and compare the results. That way you know that the tricky, clever, complicated algorithm is actually doing the right thing. An example might be if you have a really clever, fast sort, you can also throw a bubble sort in and make sure that they both come out with the same results. Of course, only in your debug version. In your release version, you ship the fast version, as long as you know it verifies. And then automated unit tests, that generally is tool-driven. And a unit test is a test that you write using a tool that will pound your functions with various parameters, correct parameters, invalid parameters, and make sure that everything functions the way that you expect it to work. Unit tests are individual functions, but putting them all together can lead to test-driven development. I do games, and honestly, I'm not sure how to make test-driven development work for games, but if you work in other areas, that's something really good to look into, and it would be a whole talk of its own. So I'm going to just move on from there. Best practices. Eschew obfuscation. You guys familiar with that phrase? Okay. Eschew obfuscation means avoid unnecessary complication, which of course, using those words is unnecessarily complicated. Err on the side of caution. Write self-documenting code. So I've been giving examples of variables A and B. Don't ever use variables A and B. Use variables that make sense. Use variables that tell you what you're doing with it. Make sure that you don't get things so complicated that you can't follow what's going on when you look at your code. And everywhere that it gets a little complicated, make sure you add comments. He says, being the world's worst commenter. And then the debugger is your friend. Debugger is not a tool only to be used after bugs reported. Use the debugger to step through all of your code to make sure it works. Test your code as you develop it, because as we said earlier, bugs are easier to fix sooner rather than later. How many of you actually use a debugger during your development process? Okay, good, great. Well, then I don't have to spend much time on that, because almost everybody does. I'm embarrassed by the number of people I've worked with in the game industry that don't use debuggers at all, not even to find bugs. They use the age-old method of printing out things to the log files and figuring out where things went wrong. Let's see, instrumentation is using tools that automatically check for things like memory leaks, buffer overruns, dangling pointers, resource leaks, code coverage. A good example of an instrumentation tool that I use, or used to use a lot, is Bounce Checker, that checks for all of these things. And then almost all professional compilers come with profilers which measure the performance of code for optimization. But remember, you don't want to optimize too soon. Get your code working first before you optimize for speed. And some of the other things that you can check are like code quality and complexity by somebody's definition, memory optimization. Profilers can actually profile more than just the speed of the CPU, but also disk and network usage, things like that. So we come to the resource section. Some books I wanted to mention. Code Complete's sort of the Bible of this sort of thing. But kind of like the Bible, not everybody reads it, not everybody knows what's in there. It's really dry. It's got some great business cases and rational analysis of why you do things, but it's kind of hard to get through. So the second one is Writing Solid Code, which I found to be much more useful because I could get through it. But it's a little bit dated, and I think it's out of print, but it's really great, practical, talks about these things that I've been mentioning more in depth. And then if you happen to be writing C++, you want to get these two books, Effective C++ and More Effective C++. Same reason. You've just got numbered chapters on why you want to do this, why you don't want to do that, and tells you, shows practices that people use in their code without thinking about it and why they're a problem and what to do about it. You can improve your C++ skills immensely by reading those two books. And then moving on to the tools, I'm just mentioning a few of them here. PC-Lint is, as I said, my favorite. It's just awesome if you happen to be doing C++ on Windows. I think they have versions that will run in Linux. They don't have anything that will run for the Mac, and trying to get it to run cross-platform. Well, I haven't gotten it to work quite the way I want to yet. But I'll also mention that the PDF that comes with PC-Lint, that's the documentation, is just an excellent text that, again, you can read why certain warnings come up and learn a lot about the language and things that you may never have realized. As I said, over the last 17 years, I've learned a lot from PC-Lint. Other tools, Bounce Checker and Dev Partner Studio, it's now Micro Focus. It used to be CompuWare, before that it was Numega. It's pricey. It's pretty expensive, as in they don't put it on their website. Although Micro Focus just took it over fairly recently, so maybe they're changing that. But I bought it years ago, and it's really useful, and it's sort of eye-opening. The number of warnings and resource leaks that it shows up when you run your program the first time. And I'm not talking about your program, I'm talking about the number of resource leaks just in the initialization code from Windows before it even gets to your code. Other competing products to that would be like Purify, which I used, and ironically 10 years ago it was one of the more buggy pieces of software I've ever used. Ensure++, and something called Valgrind or Linux and Mac OS X. I'm not familiar with them, but they're the same idea. Eureka Log I've never used, but I've heard great things about it. It's for Delphi and C++ Builder. They haven't given a version to us for Visual Studio. But what it does is it will do the same sort of thing. It will track memory leaks and handle exceptions. And like I said, I believe that it will even email you when somebody runs into a hardware exception. And Smart Heap and Heap Agent from MicroQuill has been around for a long time, and it's basically instruments your whole memory stack, your whole memory heap, and checks it and makes sure that you're not having overruns, dangling pointers, or any of that. I haven't actually put it into any of my products, but there are other similar products like MatAccept does the exception stuff like Eureka Log, MemCheck does things like Smart Heap and Heap Agent. These are things that you can consider as tools to make your software more robust. And with that, coming to the intermission, the end of the technical bit. And so before we move to product testing, I want to find if anybody has any questions so far, or if you just want to look at the beautiful view from my hotel room here. I did lie to somebody. I told them I couldn't see the mountains, but in fact, if you look very closely right above that, I can see just a little bit of mountain. Does anybody have any questions about technical stuff? Tony?
No, not a question, a comment. If Delphi people here want to see MatAccept Pascal Analyzer come and see me on the desk after about 4 o'clock.
Okay, did you guys hear that? That's Tony Breyer says that if you want to see MatAccept and
Pascal Analyzer.
and Pascal Analyzer working for Delphi products, come see him after the last session at 4 o'clock. Thank you. Any questions about technical stuff? Okay, let's see, we've got not that much time, so I'm going to go quickly through product testing. I'll talk about types and methods of product testing, alpha testing, focus groups, beta testing, and bug tracking. So types and methods. There are three primary types of testing that you do. You do functionality testing, making sure that everything works. Usability testing, which has now got the buzzword UX, user experience, making sure that it's easy to use for users that don't get confused. And compatibility testing, that's making sure that it works on certain hardware, make sure it works on different versions of Windows or different versions of Mac, or that it will run on all the various portable platforms that you're trying to support. Testing on hardware is essential, speaking of mobile platforms. So if you're writing for iOS and you're writing for the iPhone and the iPad, you need to test on an iPhone. You need to test on an iPad, not just using the simulators. That's essential. Simulators are not exact, and since they warn you about the simulators not being exact, they don't make a real serious effort to make them exact. And so we found a lot of things that get glitchy when you're running them outside of that. And then the different methods of testing are black box testing, which is testing just like your users use the program. You fire up the program, you play with it, you make it do what it needs to do, and try every function and see if there are any bugs come up. Glass box testing or white box testing is testing that you do as a programmer where you write code like the unit test codes, or you write code or redundant functions to actually test that when you provide certain parameters to these functions that they give you what you're expecting back out of it. And I also mentioned on compatibility testing, also make sure that you test on multiple operating systems, which can be made easier with virtual systems now. So a lot of people have a virtual machine with each operating system on their machine, and for the most part, that seems to be accurate enough to do proper testing. If you can't afford 20 different boxes with 20 different operating systems on them. So alpha testing is internal private testing. Pardon me for now reading the slides a bit. But that runs during the full duration of development. That's what you're doing when you are programming and then checking the code. When you're running it, each time you get to a stopping point where everything works and you play, in my case, play a game for a little bit. That's alpha testing. When you hand it to somebody else that happens to be in your VP and wife, to run it, that's alpha testing. And like I say, eat your own dog food. Use the software as your users would. If you find something that's annoying to you, then your customers are going to find it annoying. And always start testing from scratch on a regular basis, which means make sure you clear out all your INI files, erase all your INI files, install from scratch. Don't have anything left in the registry. Make sure that all works. Focus group. Focus groups is testing with real users. And what you want to do is observe actual interaction. It can be done very simply. In our case, I do focus groups with my kids without even telling them. I just say, here, play this. And they play it a little bit, and you just sit and watch. And they don't realize I'm watching. But if they get confused as to how to launch something, or in some cases they go, and set it down, then you've learned something about your product. When you're doing a proper focus group, resist the temptation to lead or assist. And never be defensive or apologetic. Just take the information in. If you can, record the proceedings and review all feedback. Sorry about rushing through this. External testing can be either open. Open beta is when you just put your beta version out there so somebody can download it. Closed is when you invite people, or you have you can either invite people or you can have people apply to you to to participate in the beta testing. Again, review all the feedback, respond to all testers. Every time there's a report, make sure you respond to them because good beta testers are really, really, really hard to find. And so you want to make sure that if a tester is giving you, if a tester reports a bug to you, they're better than probably 95% of the other testers out there. So you want to make sure that you treat them well, give them free copies, give them free mugs, give them whatever. Keep your good beta testers happy. Every report's valuable, but don't let your beta testers design the software. That's a mistake that we made at MVP Software when I was doing MVP Backgammon Pro, and Dave Schneider, who ran MVP Software, wanted us to really be responsive to the beta testers, and so that beta test went over a year because they kept changing their minds about what they should be doing and whatnot. Bug tracking. When you get bug reports, make sure you keep track of them. Things to include in your bug reports. And I'll just say that we use WordPad. It works fine. Sometimes we keep extra data in email because I get stuff emailed, and so I'll just note that I've got an email that refers to it. But make sure that anytime you get a bug report, make sure that your bug report gets on to your bug tracker. Don't think, oh, I'll put it on later. Make sure you put it on because it's really easy to forget, especially simple bugs. Oh, that'd be easy to fix, and then you don't put it on there, and then you've got an easy to fix bug that you like get into your product. And review it occasionally to prevent regression. So review the things that you said you fixed and make sure that they're still fixed before you release your product. Let's see, whoops, I want to go back here. No, I don't. And then last slide, I'll just say on customer support. Everybody says the customer's always right. It doesn't mean the customer's always right. It means the customer always has a point. And if the customer has a complaint, then it's an opportunity for you to make your product or your service better. So listen to it. You don't have to say, oh, yes, they're right. He demands that the software should all be free, and therefore I have to give it to him for free. But if he says, well, there's no way I'm going to pay $200 for your game, then you have at least a piece of feedback to consider as far as pricing is concerned, for example. And also remember that when you're doing mass market software, when you have software that's out on download sites or on your site to be downloaded, that for every reported problem, there could be hundreds or thousands of users who didn't even bother to tell you about the problem. So one bug report can represent a lot of people. And never get defensive or offensive with customers or users. It's hard not to get defensive because they're criticizing your work, but they're helping you by doing so. And so never get defensive. And I say or offensive because I've actually seen people respond to bug reports with a little bit of vitriol, and that's a really, really bad way to deal with customers. And I think I've finished right about at an hour, if my timing is correct. So, does anybody have any questions, especially about that second part that I just rushed through a lot? Okay, so if not, then note the Twitter address and the GameCraft blog. I don't have the slides up there yet, but I will announce them on both places if you want them. They should be there within a week. Thank you very much.